G'day all, Mark at Southern Cross Amateur Astro here, and welcome to another video where we're going to take a bit of a deeper dive into using astrophotography tool in the installed simulation mode. There are a number of ways you can do this, but in this video I'm going to be concentrating on the devices covered by the Sky Simulator for ASCOM and Alpaca. This particular little program gives you a simulated camera mount, focuser, filter wheel and rotator if you want to test them out, and by running in simulation mode it lets you try out various features in APT without having to pull your real gear out or having to waste valuable time under the stars trying to get something to work. You can run it through the simulator in the middle of the day, whatever you like, and just test things out. It also comes in handy because you can, with the Sky Simulator, connect your real gear as well. So you might want to test your mount to see if it's catching cables on a meridian flip or whatever. You can do all that using the Sky Simulator for ASCOM and Alpaca. I'll also be setting up PHD2 in simulation mode, which is probably something you won't want to do very often at all, but it's mainly there to test the connectivity and communication between APT and PHD2, so it can come in handy for trying a few things out. Now this will be running on ASCOM Platform 7. Apparently the simulator would run on the late versions of Platform 6, but I've got Platform 7 installed and having no problems with that at all. I'll be using PHD2 version 2.6.13 and APT will be version 4.63, which is the latest version available to those on a subscription. The Sky Simulator, most of this video will now cover version 3.0.4b. Over the last 2 weeks there's been a number of different versions, as we've discussed with that, because this is what's been delaying us. Been discussing with Han various little issues we've been having with it, and he's been very responsive and fixed them all as we go along when he can, and he's even added a couple of new extra features as well. But you may see a section or two where I've used, you know, maybe 3.04 or 3.03b or something, but the newer version won't affect what happened in those sections. So that's just, you know, in case you notice I've got a different version number on some of these as we go through. But this video update has been long delayed and well overdue, and it is going to be quite a long video, so I think we'll get straight into it. So what am I going to actually be covering in this video? It'll be the requirements for running the simulator and APT together, the download, install and configuration of Sky Simulator for ASCOM and Alpaca. If you want to do simulated guiding, I'll be going through PHD2 setup for a simulation in that. Then I'll actually run through APT simulation, connecting to the various devices that the simulator has. There are certain things you need to do, so I'll be covering that as well. And finally, if you want to connect your mount or a rotator or whatever and use that with the simulator, you might want to just test and see if your cables get snagged on a meridian flip or whatever. I will cover doing that as well. So let's get in and have a look at what we require to get it all working. So what you need for the APT simulation is really not much more than what you need to run APT normally. ASCOM Platform 7 or newer is suggested. As I've said previously, you can run it on the last versions of 6, but I found no reason not to use Platform 7. You need to have APT installed as normal, some plate solving software installed. The simulator does recommend ASTAP, but it does work with others if you're not comfortable using ASTAP, but I'll be using ASTAP in this one. Of course you need to get in Sky Simulator for ASCOM and Alpaca. If you want to do simulated guiding, of course you'll need PHD2 guiding. And if you want to test your real gear with the simulator as well, you need to have the drivers installed and configured so they work correctly. But that's everything you need, so we'll get straight into it and go into installing the Sky Simulator for ASCOM and Alpaca. Okay, so now we're ready to download and install the Sky Simulator. At this point I'm assuming you've already got APT installed, ASCOM Platform, PHD2 if you want to set that up in simulation mode, as well as any drivers you need for equipment you might want to test live with APT, because I'll be doing that at the end of this. I'll be connecting a mount to show you how you can work it with the simulator while working with APT. So first of all, just need to go to this website here. I'll drop a link in the description, and simply click on the download button here, and that will get you the latest version. As you can see at this stage, it's 3.0.4b. It may be slightly different when you get here, and it's been doing a lot of work lately, but it'll just download the latest version, whatever you've got there. Now, the Sky Simulator comes with a star database installed called the G14, which I think is down to magnitude 14 stars, and that's the one I've always used for the last couple of years. But you do have an option to download another database for it, the G16, which you can download and install into the Sky Simulator directory, which takes you down to magnitude 16 stars, which may come in handy, especially if you're using a longer focal length and might need new extra stars to be able to simulate your real sky in that situation. But that's up to you. If you want to get the extra database, simply go to Files, Program, and at the bottom you've got Star Databases, and you'll see this G16 star database. That's a 253 megabyte download, and when you consider the original one with a star database already built in is only 59 or something, less than 60 megabytes, you may not want to get this. But if you do, simply click on that and download it. I've downloaded, I've never really used it before, but I just want to show you how to install it and how it's available. But like I said, I'll post a link to in the description for this one, and you can set it up and do whatever you wish, whether you just run with the standard G14 or go with the G16. So I'm just going to close that one there. Now that we're finished, and as you see, I've got them downloaded on my desktop here, and I'll just run them from there. So to install is quite easy. Simply run it. Yes. Now, depending on what versions of Windows you're running, you might get a blue screen up here saying that, you know, Windows doesn't trust it or doesn't know who wrote the program. Simply click More Info and install anyway. I've never had any problems downloading hard stuff from there, so it's all good. I just leave everything as the default, simply because later on I might want to do something. I want to be able to find it without having to think of where I put it. Or if you update something, especially with your other Sky astrophotography apps, you might want to just do an update, and it's easier if things are installed in their default locations. Now normally I'd just run Sky Simulator from here, but I want to show you how to install the extra database. So just click on Finish, and you now have on your desktop a Sky Simulator shortcut. Now, installing the G16 database is easy. I'm doing this on Windows 11. In Windows 10 or earlier, you might have to go a bit different, but basically the same idea is to open the zip file and copy the files in it into the install directory for the Sky Simulator. And the default directory, of course, is under Program Files, and you'll see Sky Simulator. All I do is simply Control A to select them all, and just drag and drop them in there. And this will come up and it'll tell me I need my administrator permission, and away it goes. 290 files, so it just takes a few seconds to copy across. As I say, you don't need to install this database. The G14 that comes by default will work, but if you don't install it, it won't be available to select in the simulator. If you do, it'll be available if you wish to use it. Pardon me. So that's done. I can close that. Now it's just a case of moving in and configuring the Sky Simulator. So simply start it, and this is your default screen. Now start off on your image source pages, and this is the source for images you're going to get displayed in APT. You have several options. You can download them live from in real time from NASA or ESO. I don't really like the NASA images. You get, especially some of the bigger targets and that, they're stitched together images, so you don't get a nice clean images. So I prefer the ESO ones most of the time if I'm downloading it. Just remember that it will rely on your internet connection, how long it takes to download these images and process them. So unless you really need to or really want to, I wouldn't really bother too much. You really need to start delaying what you're doing in APT to allow time for new images to become down if you use that way. But when I go in later on to connect my mount to the simulator, show you how to do that, I'll probably have a quick look at that and just show you how it works. Then you can also have just a single file from your disk. Basically this means no matter whether you move your mount and the camera and everything, the same file will be displayed all the time. It's the quickest way to do things, but it's not realistic for moving around the sky. You can't do things like go to pluses, which you can do if you set it up right for the other ones, but that's up to you. But it really depends on what you're testing at the time. So that could be a way you want to do it. The easiest way is to use the artificial sky. So this is the database, as I said, the G14. Because I've added the G16, it's now available if I want to select this, but I'll just go through this one on the G14 anyway. Next is your focal ratio, and this is, you put in the approximate ratio of the telescope you're using. Mine's 5.9 or something without a reducer, so I put in f6. Simple as that. The lower the focal ratio you put, the brighter and the faster images will come down, just like in using a real telescope. And just a note, if you have any time you want to find out a little bit of information, simply hold it over it and it will pop up. So, focal ratio f7 for 5-second exposure will go down to so you need to do 5 seconds at f7 to get a magnitude 14 star. But you can do it through longer exposures or whatever. But by putting the lower focal length, it takes less time to get all the stars in it. Directly under that you have flip the image. So if you want to flip the image or even rotate the angle of the image, you can do that in here. Just note that the more things you try and do with the image, the longer it'll take it to get processed and downloaded. You can even add hot pixels if you like. For this I don't really ever bother about it, but it's up to you if you want to do that. Probably the next most important thing, the next most important thing is this plotted info, and this is what's actually displayed on an image that you take, or a simulated image that you take. And you can display anything from all the names of various objects in the sky. You can get circles around deep sky objects or whatever. So no labels, just gives you, what that gives you is circles on your screen around any deep sky objects that are in the photo. You can get the HFD, the half flux diameter. The info, I don't know whether that's any different to all labels. I haven't used it enough to check out exactly what it does. You can get just the object names. There's no circles or anything else around them. The one I generally use is no deep sky, and that gives you an image just like you'd shot one yourself. I think in this one I might try object names, but I'll see how I go. No stars, that's just like having a cover on your telescope. I don't know if you'd want to do it while you're doing the simulation, but you might want to. But if you're going to run PHD2 in simulation mode, you will need to use this to create your dark library. So that's just one you've got there. I don't worry about the northeast indicator, simply because if you plate solve an image in APT, you get a north pointing arrow anyway, so you can use that for your directions. But I might try something different here and just put on the object names. I don't normally do that. I just normally leave it at no deep sky. I just want to see what it looks like. Just one note that if you go with just no labels and you're getting the circles on your images, it may cause you problems with solving, it may not. Or if you use the simulated guiding, it may cause an issue with your guiding. I don't know. I've never tried it, but that's one thing you can do. But like I said, I'm going to put the object names on it just so when I'm scrolling around, slewing around the sky in the simulation when I show you this, you'll be able to see where I'm pointing. Okay, the last thing we have here is the camera and system. I run a mono camera normally, so I just leave it on mono. But these are options you've got that you can use, different Bayer filters and everything else. I've never used them. I don't know what they look like when you use it, but you can do that. I mean, you've even got pincushion distortion, which could be from using a normal camera lens or something like that. The ones down the bottom, I believe, are for taking flats. If you want to simulate flats, so you can choose that. So I'm just going to select mono because that's what my camera is. The start simulation will start the simulation. Stop simulation will stop the simulation. You can also hit escape to stop the simulation. Save settings will, of course, save the current settings. I think it saves them on the fly in the configuration file as you change things, but you may want to do it after you've got everything configured how you want. Of course, save settings and exit is save settings and exit. The Go Default button will simply switch everything back to the default settings and shut down the sky simulator. So that's a Go Default and exit, but it'll come up and warn you before it does that anyway. So that's your image sources there. I'm going to skip the camera for now because there's a number of different things in there, a couple of new things in that, and there's something I need to do once I start the simulator, but I'll show you that in a minute. Your mount page. Okay, so I'm going to switch this to the Alpaca internal. As I said in this video, I want to test the internal ones on this. Like I said, you can connect to an external mount, and it can be an external simulator or your real gear, and I'll show you how to connect your real gear at the end of the video when I finally get there. So I'm going to check the internal one. You got to choose whether you got a fork mount or equatorial. So I'm just going to leave that on equatorial. I haven't bothered changing these. It seems to work fine. I'm currently using J2000. I think I'm just about due to change to J now. It's been 25 years. So I'll just leave that there. Polar alignment error. You can add polar alignment error to the mount if you wish. What that does is every 10 seconds or so it'll take a new image or download a new image to adjust for any polar alignment error you enter here. It's up to you whether you use it. I don't bother with the simulation. I'd like to think I've got it perfect. Latitude and longitude is next, so I'm going to put -36. This is my not home position. It'll put you in the middle of the ocean off my coast. Okay, the next part depends on what you're doing. There are some things that won't work if you don't set a bit of noise, and there's some things that will work in APT if you don't set it. The big thing is if you want to practice go-to pluses, or you want to practice autofocus runs, you need to add some noise or error to the mount, otherwise the images won't get updated between each one, and it can create a real problem. Like you try and do an autofocus run, it'll be a straight line and the images will be the same for the mount no matter what happens. So I add a little noise so it's quickly updating them all. I just add 0.4 and that's all I need to add in there. You can use that. You can add periodic error if you wish. I just leave that off. You can add backlash, which will do the same sort of thing. And down here it'll display the amount of error in each direction it's doing. And I'm not exactly sure what the incidental, so it adds a tracking error. There you go, 5 arc minutes or 5 arc seconds in either direction that you put it in. And that's what you do there. As I say, another reason to set a little bit of noise is if you want a more realistic guiding graph in PHD2. If you don't have any noise and you don't have any polar alignment error or anything, your guiding graph will be flat as a tack because everything's perfect. I find by adding about 0.4 noise you can then get about a 0.8, 0.9 total RMS error in PHD2, which is fine for just testing things. Pardon me. The only thing to note with this is if you're running a slower computer, this can bog down your system a bit because it's basically taking a new image every second or two to account for the noise. So unless you're going to be testing things like I said, autofocus or whatever, doing go to plus or plus, I wouldn't bother putting it on, but you may want to use it because it can spike the CPU usage. It's fine on my main computer, but I often like making these videos. I'm using the simulator on my actual Astro imaging setup, and it's only a little Melee 3Q, quite a 3Q, and it's, you know, a Celeron with 8GB of RAM, and it actually really ramps up the can really ramp up the CPU usage in that, trying to continually process images. So that's just something to consider. If you're running it on a decent computer, it's not an issue, but it's only if you're running on something slower. Next up is the focuser. Oh, I forgot to tell you what else is on this right hand side. This is just up the top here. That's just shows you what your mount's actually doing once it's started. It'll just give you the RA and deck of where it's pointing at. So that's all that is there. And you've got your sky simulation here. When you're running the simulation, you'll get a red circle which will show you where your mount is pointed at a particular time. I believe you can move it to a new location or whatever. On here, I haven't tried it. I just run it through APT, so that's the way I go there. But yeah, this will just show you. I'll give you a look later when I'm running around. In the focuser, again, you want to change it to the Alpaca. Now, this has, I think, about a 65,000 step limit. You can pick where the actual focal point is, so you can pick exactly on focus is that one. This range one, as you move further away from your focus point, when you're doing a focus run, it will adjust the half flux diameter of the stars. The further you are away, the higher they'll be, up to 10 if you get 1,000 away from it. So basically, if you've set 25,000, at 24,000 or 26,000, your stars will have a HFD of 10, but it'll gradually come in as you get closer to the focus point. So you need that to get your auto-focusing running. I get rid of the backlash, I don't like it. And these other ones here are just details that we filled in when the mount when your simulation is running. You have a rotator. I'm going to set that up as Alpaca, though I won't actually be connecting it to it. I don't have a rotator, so I don't need to test anything at the moment. I'm sure I'll get one eventually, maybe one day. Next up is your filter wheel. All you got to do in this filter wheel is make sure the settings in here are the same as what you've got in APT. So I'm just going to quickly run through it. I know what mine are. Shift L, HA, A, A3, S2, R, G, B. Don't you love my elite typing skills? Next is your image. The image that's displayed here should be the image that is displayed in APT when you take an image. So this will update every time your mount is moved. If you've got the, as I said, if you've got the noise turned on or whatever, a bit of error in there, this will update every 2 or 3 seconds. If you do polar alignment error, it'll update every 10 seconds. If you don't have either of them, it'll only update when the mount moves to a totally new location. So that's when that gets updated. Alpaca, I don't touch anything of this. This is just what's used to run the whole thing. You know, you can do some settings if you like, but I don't understand the program, so I don't touch it, so everything keeps working. And finally, the log. This just logs when you do various things, and it'll generally be mostly full of when an image is done. So it'll, you know, prepare an image, and then an image will be ready to be downloaded or whatever. That's a lot of what will be in the log. So that's everything else except the camera. So now we need to go to the camera, and you have a couple of options, and what's available will depend on your image source. So if you go to the NASA one and go to camera, you can set all these settings. I don't know how well they work because, as I said, I don't like using the NASA. These bottom ones here, your pixel size and focal length, are brand new. It's only been added in the last version 3.0.4 I think came in. So I don't know how any of that will work with the NASA ones, but I don't like using their images, mainly because they're stitched together images and they can make a real messier what things look like, and plate solving especially. If you go for the ESO ones, they have a set size, so you can't change your pixels, your width and your height of your image. You can still change these ones, but I don't know if it makes any difference on the final image. I haven't tested it, as these have only just been introduced, so I'll have to work on that. You may be able to change the pixel size, but I think the focal length will stay about the same. I'll have to check that when I connect my real mount at the end of this video. And of course, if you got the artificial sky, then you can fill in everything. So I'm going to fill this in for my real camera, just so I can show you it gets at least close to it. I use an ASI 294mm. I generally run it in bin 2 mode, simply because that's what I normally use. But it's unlike the color version. It has its bin 1 is half the size pixels, but I run it in bin 2 normally. So that's what's that, 4144 and 2822. Okay, I can set that there. I can set my real pixel size. I'm going to put in 4.63, but I find it defaults back to 4.6 later anyway. And the focal length for my, I'm just going to use it on my little telescope, is 360mm. So that's done there. And what it does is, when I click off that one, is it gives you your scale, pixel scale, your height in arc minutes, and your width in arc minutes. So that's what that does there, and it actually works quite well with the artificial sky, the built-in artificial sky. It actually does that quite well, and you'll find these settings will be pretty much the same in APT. It'll work it all out, and it'll give me the right focal ratio and right focal length and everything else for my tools tab. Then you have fast simulation, and this is basically any image you take is really right to look at after 1 second, but like anything else, you can take longer exposures and it'll be brighter and everything else. So I just put it on fast simulation. Normally you can test it on normal, turn off the fast simulation, but it works for me, so that's without a problem. Now the final thing that comes through here is you have to create if you use a program that doesn't use the ASCOM chooser, something like PHD2 doesn't use the ASCOM chooser, you need to create a dynamic link between the Alpaca driver that's built into the Sky Simulator and ASCOM, so they can work together. If your program doesn't, as I said, if your program doesn't use the chooser, you need to start it in here. If it does use the chooser, I could do all this in APT, but seeing as PHD2 doesn't, just to show you what happens here, I will do this in this program. So basically you need to start the simulation first, and then as you see, it's created an image, and if you go into the image here, that's creating an image where the mount is pointed at the moment. And as you can see, it's updating that pretty quickly because I've got the error on it. So I'm getting a lot of created images. Now that doesn't mean you're getting a whole lot on your hard drive. It simply replaces that image with a new image each time, just so you know you're not filling it up. Now I need to go back to the camera. Now to create these dynamic links, you only need to do this once and it'll be fine. But you have to do it with every different device. Well, one part of it you got to do with each different device, but you can only do the camera in here. So I go to the ASCOM camera chooser. What you need to do is click on the Alpaca and enable discovery. So then you'll get this one, which is the green light here, which is your Alpaca. That means it's discovered new Alpaca items. So you need to go in and pick up. And what I'm going to do is the camera for Sky Simulator is the normal camera, and you always have a guide camera if you want to use that in PHD2. Just a note, I don't normally use this camera in PHD2 simply because it's exactly the same camera image as what you get in your simulator in APT, and a bit too big for me for a normal guide camera, but I'm going to show you how to do it with this guide camera anyway. But but I'm going to connect that. Okay, the first time you connect it, and this particular part is what happens the first time you connect any of your devices in APT. You click OK, you'll get the pop-up saying ASCOM wants to update itself, and you click OK, and then you click OK again, and it's connected to the camera. So I can go again, camera chooser, and this time I'm going to go for the normal one. The camera sky simulator for Alpaca is the one you'll be using normally. But as you'll notice, I don't have to do the Alpaca discovery on anymore. You won't have to touch that again. But you do need to create the dynamic link to the driver, and that's okay. So there you go. This is all set up. I'm just going to stop this now. It's all set up, and we're now ready to go into APT and connect everything in there and set it up. Normally I'd go configure PHD2 first, but I need to create the dynamic link for the mount in APT first. So that's just a notice for you there. So I'll be back in a minute to connect it all in APT. Okay, so now we're ready to get going and set everything up and configure it in APT. So the first thing to do is to start the sky simulation. Start simulation. Then you can minimize that out of the way, it's no longer needed. Then go into the APT simulation, start that up. Setting up APT, most of it's exactly the same as setting up a normal run. So you just set it up just like normal, and away you go. So you go through, do all your settings and everything else, make sure they're all like things like your location and everything else are all set and correct. One thing I do in here is the filter wheel. I set it up to match what I have. The camera, when you connect it, has a minimum gain of 100, maximum gain of 1000, so you might want to set a gain in here. You only need 1 second exposures, so put all your 1 second exposures in there, and don't worry too much about the brightness. I'll work out that one day. I haven't done flats with the simulator, so there's no really need. So I'm just going to click OK. One big change I do make is go into Datacraft, Settings. Now by default the Build Images database is on. If you just leave that set at that, it will actually add the simulator images to your normal database. So you can either disable the database by unchecking that box, or if you want to create a database that you might be able to play with a bit later on, simply set a path for it. I just stick it in the same path as what the images from the simulator will go into, and that's this one here. Small spelling error by Ivo there, but I've let him know, so that might change. And that's all I do. So I keep the database. It's just so I can play with it to learn to use it and not do anything to hurt my real database. So that's all I do there. I don't worry about getting a Datacraft queue and copying it somewhere else because they're only simulated images. So that's one thing I do. Another thing you might want to do is to go into point craft settings and just increase the pause after go to. I don't know if it needs to be that long as 15, but maybe set it as 10. This is especially important if you're using the downloaded images off the internet. It's to give it time to download the images and prepare the image to be used by APT. So you need to allow that. Especially important if you're trying to do go-to pluses and everything else, because all that works in here. So click on OK for that. And then it's a case of connecting all the gear. So connect the camera when it pops up. Well, it doesn't. I don't know why sometimes on this system I click once and it doesn't do anything. So you want the CCD ASCOM connection. Click OK. That'll bring up the Alpaca. Enable discovery. Okay, so you got the green light there. Then you go down camera sky simulator for Alpaca. That's the one you want, and just click on OK. So now the camera's all done. Now to connect the other gear. So same thing with the scope. Discovery's on at the top. new device, mount Sky Simulator. That's what you want. Click OK. Now ASCOM needs to update, so yes, and then click OK again, and it will connect to the mount. So that's done now. Same with the focuser and the filter wheel and rotator if you want to use that. So you go down, focuser Sky Simulator, OK. You only need to go through and do it like this once. Once they're set up and connected, you don't need to worry about going through it again. And connect wheel. OK. Yes. OK again. And that's all your equipment connected. Like I said, the only thing you need to worry about here is to make sure all your filters are in the same order you've got them in the simulator. And I've already done all that, so I know it's all right. Now, depending on how you're connected and what images you're using, if you're using downloaded images or an own image or whatever, it's quite often a good idea to go to the cam and do a single image and plate solve it, just so you can get your settings right in your tools tab. So just do a quick shoot. This is a 1 second one at a 500 gain. So busy. So there it is there. Go to gear, point craft, scope position, and I do a full blind solve. So I hold down shift and click on blind, and it will solve the image. I'm using PS3 for this. That's generally what I use anyway, but you can use any plate solving program you want. ASTAP works, All Sky Plate Solver, etc. all work. So now that that's been done, you look down the bottom here, it'll tell you your focal length. So then you just need to go into your tools tab and enter the correct focal length here. With the new settings on the camera, it works out fine if you're using the artificial sky, but especially if you're using the downloaded images, the first time you do this, I suggest doing this so you get the right focal length, because it is a different focal length and it won't absolutely match your images. But you can do pretty much anything now. Almost anything you can do in normal APT, you can do in here. Let me see. So we're pointing at a point. Where are we pointing? Yeah, it's too close to the celestial pole in the north, so I'm just going to go a little bit more off it. So I'll go to there, and then I'm going to run an autofocus run, so just show you can do that, and it all works as it should. So there we go. You can close that. Now you need to make sure you've got focus craft enabled, of course, and Control A will bring up this. Generally it gives a pretty good curve as you go through. So I'm just going to hit run, and away it goes. This won't take too long. I've got nice short pauses and nice short images, so it'll just run through and give you an idea that you can do it without an issue. Now, as I said, to get this to work best, I found to have the little bit of variation in a little bit of error, the noise. I found that if you don't have that on, it doesn't reload a new image, but this way it does, so I'm quite happy to leave it at this. But if you do it this way 99 times out of 100, you'll get a very good curve, one that'll work for the simulation. So we're halfway through, we're imaging the fifth one. So as you can see, the HFD has dropped just a touch down to where you'd want it. Oh, a little bit better on that one. There you go. Well, we'll just let this work through. But as I say, pretty much anything that doesn't involve actually using a real camera, you can virtually do that in here. There's probably a couple of things that might not work, but generally it's okay. Now, if you find something, I don't know. But as I say, generally everything you can work on in here. You can link it to a planetarium program if you wish and use that. anything like that you can do, and to go to different objects. So just letting this run a bit longer. Just a note on this version, we thought we'd fixed a problem with the South Celestial Pole. When your mount passes through, or you've parked it in the southern hemisphere here, it can get stuck at the South Celestial Pole and never reach a target, so just be warned of that. I've put it up for Han to have a look at again. We thought he thought he had it, but it's not quite working. I had to actually restart this video again simply because of the fact it wasn't working. I got stuck on the South Celestial Pole, but I'm going to stay away from there for this video. Okay, so there we go. It's all done, completed successfully. You'll always pretty much get a good run no matter what settings you use in your settings in here. It generally comes up with a nice clean one anyway. Okay, so I'm going to get out of that. I don't want it to keep calculating at the moment, so I'm going to turn that off. What are we going to do next? I'll do a bit of GoTo and GoTo++. How's that? Just as a quick demonstration. So I want targets above 30. Yeah, that'll do. Preferably something in the north. Let me see. I don't want to go to the southern pinwheel. Oh yeah, we'll go to the southern pinwheel. It should be right. I shouldn't go too close to the pole for this, but the mount does seem to wander around a bit as it's moving, so be very careful of that. I might end up near the South Celestial Pole, and I really don't want that. So it's going there. That's good. It's got to a position. So what I'm going to do now is I'm going to take an image in that position. Just before I do that, I'll just snip into the simulator here. So it's imaging and downloading. As I said, the image tab, that's the image you're currently using. The log is keeping track of the images it's creating. Now it's creating so many images because I've added that little bit of noise into it. So just every few seconds it's creating a new image. As I say, if you're using your image source of one of these download ones, it does take a bit longer to get an image down. So that's what you've got there. If you go to the mount, as you can see, it's got the red dot here. That's where you're currently pointed, and that's all working good at the moment. So what I'm going to do now is just going to shoot another image and give that a couple of seconds to come up. So there's the new image of the new location. So what I do now is point craft, scope position, solve. And this should only take a few seconds, if that. There you go, it's solved successfully. So I'm going to sync this, go to objects. I mean, it's going to be pretty much on target. It almost always is. And go to ++. So like I said, this takes just a little bit longer than using a normal telescope, normal plate solving and everything else, because it takes, you got to allow that bit of time to download the image and get it prepared. Otherwise it just keeps loading the same image. So it's taking it, it's done, solving, and let's see how close we get. There you go, it's right on target, 0 pixels. But that's just to show you a couple of things so you can use all your various bits and pieces, and it all works just fine. Great for testing things out. So I'm going to leave this here for now, and be back in a few minutes to show you how to set up your PHD2 to simulate the guiding. So I'll be right back with that very shortly. So now we're ready to set up a PHD2 to work in simulation mode, now that we've got the camera set up and the mount set up correctly to be able to use it, simply because PHD2 doesn't use the ASCOM chooser. So with the Sky simulator running, as I've got it here, simply go to PHD2. I don't have any profiles installed on this, so it's going to want to create a new one using the wizard. So you go next. For the guide camera, you choose guide camera simulator for Alpaca and ASCOM. Normally this isn't the one I'd use for guiding. There is another camera that I prefer to use, but for this demonstration, as I said, I'm using everything in the Sky Simulator, so I'm going to pick that one. Yes, it's connected. It'll fill in the pixels and everything else. You can go up to bin 2 if you wish. What I do? I haven't tried bin 2 before. It's just that the image is so big the first time around, it's a bit hard to do. Focal length, I'll put the same as I had on the other one. Actually, no, I better not set bin 2. I don't know whether that'll interfere with the camera if I do that. Then go next. For the mount, if you hadn't set up the mount in APT, it would not be available here, but we want Mount Sky Simulator for Alpaca ASCOM. Is it connected? Yes. And next, no adaptive optics. I'm not going to be connecting a rotator, so next. And I'll just give this sim mode. There you go. Auto restore calibration, you may as well. And finish. And of course it's going to want you to create a dark library, as it's done there. So what you need to do is go back into the Sky Simulator, under image source, the plotted info, no stars. So that's as if you've put the cover over the guide scope. I'm going to set a maximum of 3 seconds in this and start. Yes, I've covered the guide scope. And away it goes. Now I'm just going to pause this for a couple of minutes while it does this, and I'll come back when it's almost done. Okay, almost done here. Just taking the second last frame right now, and then we'll have one more 3-second frame and it'll be done. And here it is, the last one. It's just come on, hurry up, hurry up. Okay, goes uncover scope, so back into Sky Simulator and put it back onto whatever you're using in here. And that's done. That's how it sets up. Now I'm going to extend out the time here, probably 3 seconds, just to allow it, that'll allow it to get the new images downloaded. So I'm going to go loop. And star select. There are stars there, you just can't see them. This is one reason I don't use this one, because it's too big a field of view. And of course you're going to have to calibrate. Oops. I'll click out of that. Oh, I may as well slew it and let it pick where it wants to. I'm going to have to slew it anyway. I didn't think to move it in APT at the time. So it'll move to the correct position to do a calibration. And then we'll calibrate it. And again, while the calibration's going, I will pause it. It takes a bit too long. It's getting there. The amount is a little bit slow to move sometimes, and I do find it wanders a bit, especially when you're in APT. So okay, so now that it's done, stabilize and calibrate. So it will start the calibration as normal, so you can see what's going on. So I'm just going to pause this while it gets the calibration, because this takes a bit of time, and I will be back shortly. And we're pretty much done here. Onto the last south step, then maybe a couple of nudges to get it down back on target, and the calibration will be done. But that's it. Now you've basically set it up as a simulator, and it's using the simulator ones from the Sky Simulator, which is good. Okay, so now it's guiding. Close that down, and we'll just give it a couple of seconds to see how the guiding runs once it gets going. So as you can see, it does get a bit of variation, which is good. Hopefully the RA will move soon. But as I say, if you don't put that bit of noise, there we go, if you don't put that bit of noise into your the Sky Simulator, the bit of noise we got here for the mount, if you don't have that in, you end up with a flat line, and that's no good for testing anything. So As you can see, at the moment it's 0.38. I haven't tested it on this slower setting of 3 seconds, but generally I get up around 0.8, 0.9, sometimes going up to 0.1, some going down to 0.7 or 0.6. But as you can see, it works, and that's the main thing. And now you can check your connectivity between APT and PHD2. You could also go in here and just play with the various settings in PHD2 just to see what each of them actually does to your image, to your graphs, and see how each change can vary it. But that's it for PHD2, so I'll just leave this one here, and I'll be back to you in a few seconds with setting up your real gear. I think is next on my agenda. I'm going to connect a mount into it and show you how it all works together. So we are finally into the last part of this video, where I'm going to connect a real bit of equipment to both the simulator and to APT, just to show you how it's done. This can be a mount, a rotator, a filter wheel, or focuser. In this case, I'm going to be connecting a Star Adventure or GTI mount, just to show you how you do it. Now you need to connect the mount in both APT and the simulator, and simply because if you don't connect it in the simulator, the camera won't know where it's pointing, so it won't know what to do. So you really want to make sure you do it in both. I'm also going to do a couple of extra little things in here, so I'll start the Sky Simulator. Okay, first thing I'm going to do is change my to a downloaded one. Now remember, this is going to depend on the speed of your internet. I've just got a new little mini router for my outdoor system, my imaging system, which seems a bit slow, so this might go slower than what I'm hoping it will. So I'm going to click download from NASA. In the camera settings, you can still set your width and size, but you won't be able to change, or you can change the focal length, but it won't do any good because it'll switch back once it's ready, because it's sort of had fixed sizes because of the images. And then I'm going to mount, and of course we want to connect to a real mount. So what I do is I go to ASCOM interface, and this will let you connect to an external mount or your real mount. Now by default it's going to connect to the simulator for .NET, which you'll see a pop up in here. So I'm going to disconnect simply by clicking on it. That's all you need to do. Then you go connect mount and simply select your real driver out of it. Now I could use Green Swamp Server, but I'm going to use my normal EQ mod, and click OK. So there you go. Because the driver's all set up and configured properly, it's connected without a problem. And that's really all I need to do there. So the big thing with choosing these image sources here, you can't add any error to the mount, which is good in a way. So it's only downloading an image when you go to a particular target, but it does mean you can't do go-to pluses or autofocus runs. That's the one, autofocus. You sort of can do go-to pluses and make them work, and I'll show you that, but you need to make sure you allow enough time for an image to download for it to work. So just be aware of that. Generally I wouldn't bother doing it with those, but I'll just show you these anyway, just so you can see what's going on. So once you've got your mount selected and connected, simply click Start Simulation. Now you notice it's got a green box on it instead of the blue box. That just means it's not the internal device you're using. And APT is simply a case of just your normal APT setup. So I'm just going to run the simulation. It'll start up, it won't find the mount of course, because the simulated mount is no longer running. Unlike other ones where you can still select the simulated mount, because the Sky Simulator connects to an Alpaca one, you need to have it running for it to be available to be selected. So because it's not running, it wasn't able to connect to a mount. And like I said, it's just like a normal one. Shift connect and select the same driver as what you're using in the other one, and OK. And now we're connected. So first of all, I'm just going to do a quick shoot here, this location. So this is one of the NASA images. and that's what they look like. They're not too bad in some situations like this, a few streaks across the sky and everything else. But I'm going to use point craft, scope position. I'm going to solve this one because I want to confirm the focal length. And as you can see, 333 millimeters. So make sure you go into your tools. I'd already set it there from a previous test, and set this to the correct one so it can solve images for you. So then I'm going to go back to gear, and I think I'll show you a bad image. What am I after? I might go to Carina Nebula. That's bad. I haven't got things I could use. Or maybe the Eagle Nebula, but I'll start with Carina. What's that? 3372, I think. I should know it. I've been go to it often enough. Okay, and go to. You might be able to hear my mount whirring in the background over there. Like I said, this is a good situation for testing your mounts moving properly, putting your gear on it, and just checking for cable snags and that, especially on meridian flips. You can do all that. Okay, so I've settling down in a new position here, and I've got the long settle time from previously when I was doing things. So I'm going to shoot, and I'll show you this one. That's the type of image you get. So that's Eta Carina, the Car Nebula. It sort of overstretches it a bit. I want it stretched, but not quite that much. But as you see, this is what you get. They're stitched together images, and they're so bright. They've got so much nebulosity in them, it makes it very hard for images to get solved. I might try it here and see what happens. I'm just hitting solve. It might solve it, it might not. Oh, it did manage to solve that one. But you get some really bad. I know Orion's bad. I think M16, the Eagle Nebula, is another bad one. I might try a couple here just to show you. And then I'll compare it with the... let's go back up the top. Lagoon Nebula, I think that's another bad one for it. And then I'll compare it with the ESO images, and you can see what they are like. But like this, using the downloaded images does make it so your mount is perfect. It'll never be off target, which can be a bit of an issue. And like I said, you can't really test GoTo++ much, because it'll always say it's on target. Now I think if you leave it long enough time to settle, it can do it with GoTo++ if it moves slightly. Okay, so I've got this long settle time for these downloaded images. So if I go to, it's downloading an image. It really slows down this system if I do that. I didn't want that because the downloading, so now it's ready, but downloading on this system is not good at all. What am I doing here? H. So I'll go quickly back into APT. We'll shoot an image. I mean, this is my Astro imaging rig that I'm recording this from, and as you can see, look at that, a big line straight through the middle. So they're not the best images to use. Things like Orion Nebula is really bad. I think M16's not the best either. We'll go have a look at that one. I'm just trying to remember because I don't use this one often off the top of my head, so I don't use this one at all. I hate it. So you've got to give it time to download it. Now this computer's pretty slow. It's only a Celeron and that. It's great for normal imaging, but the processing it requires to get these images downloaded and ready for display and everything else just slows this computer right down. Everything pretty much stops while it's doing it. Okay, so that's settled. I'm going to shoot, Hopefully the new image is ready. There you go, that's the Eagle Nebula again. That's, you know, one image over here, another one stitched in here, and it'd be okay if they're all from the same source, but because the image is from different sources, you get these lines, and it's just no good. And like I said, I think something like Orion is the worst one. But what I'm going to do now, I'm going to go into here, and for the image source, I'm going to switch to ESO. The big problem with ESO, it has a restricted image size. As you can see, it's greyed out here. It has its default one, which you can't change. That's the only problem with that one, but the images are much better. So I'll go back here. It's got the new image ready already. That's it there. So I'm going to shoot on that, and as you'll see, the images are much better. I can actually make that a little bit brighter. Yeah, you can barely see it. So, yeah, but the images are much better. There's not all the lines going across them and everything else. So we'll go back to Eta Carina just quickly. Okay, and go to. So this will go to that location. I'll turn off the target. Oh, that's what I haven't done. So what I need to do is to go in and take an image, solve it. Oh, actually, I can point craft and plate solve this one. I should still be able to do it. It might take a few minutes. I'll just blind solve it. It might be quicker to take. I'll wait for that to settle. Oh, it's downloading the image. As you can see, the numbers are stopped up here. It's because, you know, it shoots up to 30, 40, 50% CPU use while it's doing this, and it's solved it. And you can see the focal length now says 561. So if I want to be successful on the other ones, I'd have to go in here and change the focal length to 561. So just remember that if you're changing between your image sources, you do need to get them right. So now that I've moved to a new location, I'll shoot. Oh, I can't start a new. Wonder why that is. Well, I'll disconnect the camera and reconnect and see if that fixes it. Thank you. Something happened there with the camera. I just had to disconnect it. So as you can see, it's a much cleaner image of Carina. I could have shot that with a, I'll go with 500 and shoot one again. And just remember that the camera has a gain between 100 and 1000. So this is a 500, and it doesn't look too bad. That's what it does. But so there you go. That's what I prefer, either using the ESO ones, which, as I said, does slow down a lot. You've got to wait for it, but it only takes an image when you're in a new location. So you can sort of use, like I said, you can sort of use Go2++, as long as you've in your settings have set an extreme. I've set 15 seconds. I don't even know if that's long enough to do this, so I'm going to try and do it. So okay, I'll sync it. Objects. Okay, and Go2++. I mean, the camera, it says the camera moving, but I don't know if it'll get me a new image. It's going to be right on anyway, so it's not going to matter. But you can't really test it using these images because there's no really any movement in your camera. Any way you do it, the mount's going to be almost perfect in the simulator, no matter what you do. So 10 pixels it reckons. Okay, so that's it. That's all you need to do. And as I said, it's the same if you want to go in and use your focuser. The wheel doesn't really matter, whether you use a real one or the one in them. You just need to make sure the filter's the same way around, and you can do the same with a rotator if you have one. You can test real ones. But that's how you do it to connect your real gear to APT and get the simulation working with it. And like I said, it's just the same as connecting it as you would normally. You just got to remember to connect it to the simulator as well, and to remember to connect, if you're going to try PHD2, which won't work very well with this simulator, you have to connect it in CHD2 as well. But I would not use PHD2 if you're using your real mount, because it can have a bigger, it just won't work. Just won't work, because the camera, well, it will work if you're using, you need to make sure you're using the image source as the artificial sky. That's the main one you've got there. But that's it, all done at last. I hope this has helped someone. It's been a long video, and I've re-recorded bits and pieces of it at different times, and I'm just glad to be finished it. So if you have any questions, leave them in the comments below, or go to the APT forums and drop us a line in there, and we'll help you if we can. So take care all. I will see you in another video, and hopefully I might be able to explain something real. I'm going to park this scope. Yes, and I'll see you all later. Take care.